Hello!
Hello.
How's it going, guys?
No.
Sounds like we got a full house. You're a sniper in CS:GO? Oh, is it like different strategy with Roblox? Oh, okay. Oh, I see. Isn't gun game where you you get like all the guns like one at a time? Each kill you get a new gun or something? Yeah. That's really fun. That's one of my favorite gameplay mechanics. Nice. Oh yeah. Right. Isn't one of like the major like swagger moves to like as soon as you get a successful shot, then you like whip out your like melee weapon and like do a trick or something? Oh no, okay. Fair enough. Okay, so what are we gonna do today? Let me just pull up some stuff. I came very close. I mean, I've finished. I think it's finished. I did want to send it to some other teachers just so they can review it. I'll give you kind of a glance at it. Like I'll let you see it, but I'm gonna hesitate to distribute it before it gets signed off on. So here it is. Yeah, so I think we'll just keep it kind of short and sweet today. I'll just sort of show you kind of the gist of the document. Oh. Oh yeah. Hold on a second. Just gotta copy this. Go on here. Paste and go. Okay. Yeah, I think I can actually just open it up on here. So yeah, what I'm gonna do, I'm just gonna open it up on here, and like you can kind of have a glance at it. There may be just a few changes to it before I distribute it. Just be aware that this is not the final copy, but it's pretty much done. I want to make sure that it meets the requirements that the math department has made. So yeah, here it is. I'll just open it up here. For some reason on iPad, it's the formatting is a little bit wonky. So like this kind of like is doing that. Some of the images too, like I don't know why this picture is here and not where it's supposed to be. I think it's supposed to be like further over here. I'm gonna just steal my mouse and put it on my iPad so I can point at things. Okay. Aha. Yes. Okay. So yeah, I think the like this picture is supposed to be over here. It looks better on the computer. What I'm gonna do, I'm gonna save it as a PDF, and then you can just look at the PDF, and then all the formatting will be much better. I mean, like you can see this equation is like cut off by the column for some reason. Not sure why. Yeah. So this is it. So it's kind of split up in the following way. So again, this is not like a final copy, but this is just the gist of it. So the first bit talks about just what the document is. There's a level 1, level 2, level 3 type of question that I'll put on here. So the gist of it, I'll just kind of show you one of the sections here. So I want to make sure that you can actually see this. Oh, and I can't. Hold on a second. Just give me 2 seconds. There we go. Okay. Yeah, and you can see that just fine. Okay. So, and I'll even do this so it's away from my camera. There we go. Yeah, so here's one of the sections. This is probably the biggest one of the year. Like, if there's one thing that you can take away from this class, it would be like one topic, that is. If there's one topic that is important in this class, it's quadratics. So having a good understanding of quadratics is like the main thing that your teacher next year is going to expect you to be able to do, is just to be familiar with quadratics, expressions, equations, and functions, and that kind of thing. So this is like the topic, and then within that topic, these are the skills that I expect you to be able to do. So things like factor a quadratic expression. We did a lot of that. Use the quadratic formula to solve equations. Explain why some quadratic equations have no solution. Right, that has a lot to do with the quadratic formula, right? That discriminant piece. Recognize and factor a difference of squares. Recognize and factor a perfect square polynomial. Graph quadratic functions in standard form and in vertex form, and then completing the square. So those are like the main skills for quadratic expressions. And then here I've got several just sort of sample questions. And the questions, these are things that you can, on your own time, maybe sometime over the summer, or even like now, you can try answering these questions for yourself. So the idea here is that I'm going to be giving this document to the teacher who is teaching grade 12 pre-calc next year. So they are going to take a look at this document, and they will assume that that these are the topics that we've covered. I shouldn't say they assume. They will know that these are the topics that we covered and the main focus. And then these are the types of questions that I've sort of come up with that sort of describe like the level of depth that we covered in each of these topics. So a level 1 question, I'll just quickly scroll back up to the top. Level 1 question will be some things like basic definitions, right? Do you know what a discriminant is? Do you know can you define what a quadratic expression is, right? Just definitions. Calculations, just like can you solve this problem? Just all symbols, no problem solving, just straight up can you calculate this? Like graphing things, just straight graphing, like nothing too abstract. And then basic solving. Level 2 type of question would be like the application of the definition. So like I might ask you a question that uses some words that you would only know if you knew your definitions. Explaining things. I like this one, this identifying errors and correcting them. We didn't really do too many of these in class, but I think they're really good questions. So I threw a couple on this document here. So that would be kind of the thing like, Susie solved this problem and Susie made a mistake. Find the mistake and correct it. So I really like those types of questions. I wish we had done more of them in class. And then the another one is more complex solving, and then level 3 is like kind of a deep understanding. So explaining a process or a concept, relating concepts to other concepts, so like making connections, kind of like what we're doing with our project, and then problem solving. So when is not obvious what you're supposed to do, and you have to kind of actually interpret the problem and really think quite deeply about how it works. So that's level 1, level 2, level 3. Level 1 is like I expect everyone who's participated to be able to do the level 1 question. So those are the type of questions that if you showed up then you should be able to do these problems. Like you may, I'm not saying that they're easy problems. Like we're in grade 11 pre-calculus. Like this is a challenging course. The level 1 questions aren't easy. Like I'm not saying that they're easy questions. Like there are no easy questions that I put on this document. But they are the level 1 questions. So those are the questions that like are kind of like, here's the new material that I showed you, and these are the very first questions that I would ask you, right? Level 2 would be kind of like, these are the questions that I would put kind of like on an assignment or on a test or something. And then level 3 questions, that's the kind of question that like I might put like one of those questions on a test or an assignment, or maybe it's something that we would, if like if we weren't doing remote learning, then we might just like spend a whole class like just looking at this one problem, right? So those are the different levels of questions. And when I've spoken about this with my other classes, I was talking about them with my other classes today about this stuff. And the idea is that these questions are not going to be worth marks. Like this is not an assignment. This is a document that just outlines what we did this year in terms of the topics and the skills that we've learned, and the questions are kind of just an indication of the types of problems that you could try, and those are the questions that I would hope you'd be able to do. So the idea here is that this could be used as an assessment tool to determine how, like what level you're at in this class, because it's without a final exam and without like a final assessment, it is difficult to determine exactly how much of this stuff you know. So yeah, this may be used next year by next year's teacher as an assessment tool. I don't think that they would use these exact problems, but they would probably say, okay, well these are the topics that we've covered, so I might ask a problem similar to this, and then they'd be able to see which questions you were able to solve. So yeah, this is quadratics. You can kind of see that these are kind of fairly straightforward questions, kind of like warm-up questions. So give an example of a polynomial that is a difference of squares, and then factor it, right? So do you know what a difference of squares is? So that's it's a definition question, right? So write this function in vertex form, right? So that would involve completing the square, that kind of thing. Here's a graph, right? I've given you a graph. State the x-intercepts, the axis of symmetry, the vertex, the vertical stretch, and then write the equation for this graph, right? So those would be kind of level 1 questions. Level 2 questions, so this, I've got a word problem here. So the sum of, so two numbers have a sum of 9, product of 20, blah, blah, blah. Write a quadratic equation in one variable that represents this situation. Here's a correction question. So a student thought that this number has no solutions because the quadratic equation is not factorable. Explain why this student is incorrect, right? Another one, yeah, here's how does a discriminant play a role in the number of solutions in a quadratic equation? So just kind of like a little explanation. And then these are the more challenging ones. So level 3 question. By the way, a lot of these were from your book, right? So a lot of these actually are questions that were assigned throughout the year. You might recognize one of these questions or two. And if they weren't from your book, so remember, this is your textbook. This is your textbook, right? And then I also had this extra book that just has a whole bunch of questions in it. It's just kind of like, it's a student workbook. So a lot of the questions I just pulled from here. So like these aren't like my own sort of super evil, challenging, hard questions. Like these are questions from your book. So that's kind of the main primary source. I did look up some other problems on the internet just to try to find some more interesting ones, and I didn't want to stick just to one book, because that would in some ways you could interpret that as plagiarism in some sense. So I made sure to kind of mix up my sources a little bit, but for the most part, they're from your book. And sometimes if it was a question that I know that we had assigned already, then I just changed the numbers up a little bit so that it wouldn't be kind of a repetition thing. So yeah, another one here is like, so here's the roots of this quadratic. The roots are 6 and -2. So how can you use those roots to find the axis of symmetry? I think that's a really good question. And we looked at this just very briefly, but if you have a deep understanding of the way quadratics works, then you should be able to figure that one out. And then here's kind of a problem-solving one. I like this type of question. And I think we had a question very similar to this on, I think, like 2 assignments ago. So yeah, this was an interesting question here. And then here, the next big topic is rational expressions and functions. So these are the skills that I'm hoping we've obtained throughout the semester. So simplify rational expressions and state all non-permissible values. Perform operations such as addition, subtraction, multiplication, division of rational functions. Actually, that's a typo. That should say rational expressions. I don't have my keyboard attached here, so I'll do that later. But of rational, yeah, because you don't really add. I mean, you can add functions, but we think of them as expressions when we're adding. So that should say expressions. And then graph and analyze reciprocal functions. So we did a little bit of that. There was some on the latest assignment on analyzing reciprocal functions. So yeah, level 1 question would be like, just define a rational expression and provide an example of one. Okay, I'm hoping you can do that. I really hope that you can do that. That's something that I hope everyone can do. Simplify and state all non-permissible values in this expression. So you can, like, if you've done this type of thing before, you should know right away, like, what to do, right? Like, okay, yeah, probably gonna have to factor that, and maybe x plus 3 is a factor of the numerator, and those can cancel, and that would give me some kind of non-permissible value, right? Now we're gonna, and this one here is add, simplify, and state all non-permissible values of this this little expression here. So, oh, look at that, they've got a common denominator, right? So we can add them, and I'm sure you can kind of imagine that there'd be some steps to do. Then stuff like least common denominator. So, so write the least common denominator of these rational expressions. So look at the denominator of that. Think about the factors of that. Think about the factors of that. What would the least common denominator be, right? Level 2 type of question, a little more challenging. So here we're asked to just write the least common denominator for these 2 rational expressions. So very similar question to this last one, but the denominators are much different. Okay, so you might have to do some factoring and that kind of thing. Another one here, so add, simplify, and state all non-permissible values in the following. So yeah, we'd have to add all of those up, simplify, and then you'll probably have some non-permissible values that you'll have to worry about. So you might also have to be thinking about least common denominator here. Again, here, just simplify. So this is going to be kind of a, it looks like a simple question, but there's a lot of algebra that you have to do with this question. Here's a question again about making some mistakes, right? So correct their mistake. Here's one. We had almost this exact same question on, in fact, we had almost these 2 exact questions on the last assignment. So here's one, graph a linear equation, or a linear function, and then graph its reciprocal, right? And here's another one, graph this quadratic, and then graph its reciprocal. And then a level 3 type of problem. So yeah, explain how to calculate the least common multiple of 2 rational expressions. So that's like an explanation one. This equation is supposed to be underneath here. Like I said, the formatting is all messed up for some reason on my iPad, but yeah, simplify the following, state all non-permissible values. So this is a big question, right? You've got to, subtract and multiply or divide. So there's a lot going on here. This is an explanation one. So explain how the roots of a quadratic correspond to the blah, 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 right? Explanation. And then below, in other words, above, so this graph right here, that's what this one is referring to. Again, I have no idea why it's up here, but it should be down here. So it's a graph of a reciprocal function, and it again, for some reason, this is supposed to be over here. So it's basically saying, yeah, this is a reciprocal function. It's a reciprocal of a quadratic function. That's what the hint is. F of x is quadratic. So find the original function, right? We had a question very similar to that on the last assignment. And then comes system of equations. So this was the very last topic that we did. So I made it fairly short because we didn't spend too much time on it. So these are the skills. So find the intersection or intersections if they exist in the graph of two functions. So I should be able to give you two functions. You should be able to graph them and find where they intersect. And then also to use algebraic methods such as elimination and substitution to solve systems of equations. So basically doing exactly this, except using algebra, so no graphs. So these are the level 1 questions. So just asking, I think this is one of the very first things that we covered when it came to systems of equations. So what are the different possible outcomes? Can you have, like, I don't want to say it, but how many possible solutions can you have? What's the minimum number of solutions that you have? Here's one. So you could use Desmos for this one. So use technology to state the number of solutions in the following solution or in the following system. So you could just graph both of those in Desmos and then just observe. That's how many solutions I have, right? And then you could use algebra to calculate all solutions to this system. So again, this is a challenging question, and like the level 1 questions are not easy questions. Like there are no easy questions on this document. That's not the point. Like this isn't like a warm-up exercise things. These are the questions that I expect you to be able to answer. Like I really want you to be able to answer these level 1 questions. Like I would like it if everyone could answer all 3, but I mean I have to be realistic and know that that not everyone has the same understanding of these topics, right? Some people understand them better than others. So this is kind of a way to differentiate your understanding, right? So a level 2 question would be that I think this is a correction question. So yeah, I think I think I came up with this question on my own actually. I think it's a good question. Yeah, and then provide an example of a system of equations with one linear and one quadratic equation that has exactly one solution. So that's kind of a constructive question. You have to construct a system. And then level 3, so explain why some systems of equations have no solutions. So there's a lot of different reasons, but you can kind of come up with your own wording to describe that. So how can you use the discriminant to determine the number of solutions in a system that contains one linear equation and one quadratic equation? So how does the discriminant play into that? I heard something. Did someone have a question? No? Okay. Yeah, and then another one is, yeah, without solving or using technology, determine the number of solutions to the system. So don't like go deep into algebra. Don't go using technology. Just by observing these two equations, can you determine the number of solutions that this system has? Not impossible, certainly not impossible, but you do have to have a deep understanding of what's going on behind the scenes. You also need to be very good at graphing quadratics. Mind you, I gave you this one, which is like the most straightforward of all quadratic equations, right? Y equals x squared. That's like the baseline quadratic equation. It's like the original parabola, right? And then we've got y equals x minus 1. I'm sure we can kind of imagine what that looks like. So do those two functions, do they have any intersections, right? And then this one is kind of like a long word problem. I'm not going to get into it, but I'm sure you could read it in your own time. So that would be the systems of equations. Next up, we have radical expressions. This was a big topic. We spent a fair amount of time with radical expressions and equations. So the skills that I'm hoping that everyone was able to obtain this semester is that you should be able to simplify radical expressions, rewrite radical expressions into entire radicals, rationalize a denominator, solve radical equations, and then perform operations such as addition, subtraction, multiplication, and division on radical expressions. Level 1 question, definitions, right? These are the definitions that I really hope that you know, right? So in this expression, can I zoom in here? No, I cannot. Oh, I can. Nice, look at that. Oh, I'm going to keep it like that. That's much better. So in this expression, the nth root of a to the power of b, identify the index, the radicand, the exponent, right? Do you know what those words mean, right? Do you know what the index means? Do you know what the radicand means? Do you know what the exponent means, right? I'm really hoping that you do. What is the difference between a simplified radical and an entire radical, right? Another definition. Write the conjugate. So that was a word that we learned, conjugate. So write the conjugate of a plus the square root of b. Can you do that? Not a heavy calculation question. Like there's really nothing to calculate there, but you do need to know what a conjugate is. So if you know what a conjugate is, then it's just a matter of writing it down. Next one is to convert the radical expression into an expression that uses a rational, in other words, a fraction, exponent. So here's this radical expression. Can you rewrite this just as a power, right? Something to the power of something else. Here's one where I want you to simplify this, and here's one where I want you to write that as an entire radical. So those are all level 1 problems. Level 2, a little bit different. How big can I go here without it? There we go. Oh, that's as big as it lets me go. Okay. So here's a radical equation. So solve this radical equation. Okay, hold on just 1 second. Okay, I'll carry on. Here's one where we just simplify, so you kind of need to know about your order of operations here and things like that. Simplify and state restrictions on the values, right? So are there any restrictions on these values at all, right? Here's another one where I want you to explain a mistake. This one is actually it's a little more subtle than you might think. You might look at this one and say, I don't even see the mistake here. It's very subtle. You really have to remember some very important things about radical equations. And then this one, rationalize the denominator. Very similar to this, right? You need to know about conjugates. Okay, level 3 type of problems. Explain why you cannot take the square root of a negative value, but you can take the cube root of a negative value. Okay. Next one, I want you to generalize that idea. I want you to generalize the above idea using the notion of odd and even indices of the radical. Okay. So again, that requires a deep understanding of how this stuff works. Next up, we've got to solve this radical equation. Make sure to check for extraneous solutions. And then here's a cool word problem about a Japanese board game. Kind of a neat question. And then the last one, we're almost done here, is on sequences and series. So when it comes to sequences and series, the skills, I just thought I'd keep it simple with the skills, is just analyze them. So do you know about arithmetic and geometric sequences and series? So technically that's 4 different types of things, right? There's arithmetic sequences, arithmetic series, geometric sequences, and geometric series, right? So that's That's 4 different topics all in one little sentence. So instead of being like, do you know about arithmetic sequences? Do you know about arithmetic series? Right? I just put it in one sentence. So level 1, just some basic definitions. What's a sequence? What's a series? Right? You need to know that. Provide an example of an arithmetic sequence. I think that was like question 1 on our first and only test. Provide an example of a geometric series. Write a formula for the nth term of this sequence, right? So first you have to determine, is this arithmetic or is it geometric, right? Do you remember those formulas, right? Okay, so given the first term and common ratio of this geometric sequence, write the general term. So in other words, the nth term, right? A formula for t sub n. Here's another question. This is a word problem. It's about a farmer and trees and stuff like that. So this one you may have to just relate this to sequences and series. So how does this relate to sequences and series? You may have to say, okay, well, is this like a sequence? Is it a series? If it is one of those, is it geometric or is it arithmetic? What am I trying to do here? That kind of thing. Does the infinite series converge or diverge? So this one requires you to have an understanding of those definitions of a convergent and a divergent infinite series. And then this one is missing the picture. Just like all the other ones, the pictures are all messed up. So the picture's up here. It's supposed to be down here. But a rectangle has an area of 1 square unit. So this rectangle is 1 square unit. That means that the shaded area here is 1/4. Right? In the diagram below, each step involves shading in 1/4 of a rectangle. So here we're shading in this rectangle. The next step we've shaded in this one, and we've kind of split up this corner into 4, right? And we keep doing that over and over and over again. What is the area of the shaded region after 5 steps? And what is the area after an infinite number of steps? So here we have to have an understanding of an infinite geometric series, right? That's what that question is really about. And then here is this one is actually very similar to the other problem. So the length of an initial swing of a pendulum is 90 centimeters, blah, 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 blah. So probably looking at a geometric series here. So you have to think about what the ratio is. I would say that this question is actually, excuse me, this question, the second question, is much easier than the first question. This first question is a challenging one. It's very, very challenging. But this one, I think, if you can do the first one, you can do the second one, right? So yeah, that's the document. And I was just reading my text message here, and it looks like I got the thumbs up on it. So I'm gonna just edit it. I'm coming into school tomorrow, so I'm gonna edit this and just sort of polish it a little bit, and I will export it to a PDF. I may also sort of change the introduction here. I kind of just spat this out. I didn't really put a lot of thought into the introduction here. I just wanted to have something. And I'm wondering if I can look at this. Oh yeah, print layout. That's what now it'll look better. So I think now the pictures are, yeah, here we go. This looks so much better. Yeah, I think it was just like on, what do they call that, web layout? Or just non-print layout? Anyway, so yeah, this looks, yeah, you can see this looks much, much better. And I don't know why it's being all weird, but yeah, so now you can see that where the pictures are supposed to be. And then, yeah, see, that's where that picture is supposed to be. So this is very close to the document that I'll give you tomorrow. I'm just gonna tweak it a little bit, kind of polish it, make sure. I think, what was that definition that I had wrong? I think it was, yes, rational. This should be, I don't know where my keyboard went. Here. Rational expressions. Come on, why can't I spell? There we go. Okay, so simplify rational expressions and blah blah blah, and then perform operations, I should say on as well. This is a very poorly worded sentence. Yeah, because you perform operations on something, not of something. Okay. So do you have any questions? So if you're on YouTube or Discord, do you guys have any questions about the document? I think that the biggest question that I had with the other grades was like, oh, is this worth marks? Like, do we have to do this? Like, no, this is for you. Like, this is the whole point of this is to give you an idea of what the big ideas of this class are. Like, if you went through the Manitoba curriculum and looked at the grade 11 curriculum, you'd notice that there's things on this document that there's things on the curriculum that are missing on this document. So the curriculum is bigger, but it's because I didn't focus on it. I kind of boiled down the curriculum and I looked at what I felt was the most important for us and kind of fit with our narrative of the class. And yeah, that's what we did. So yeah, that's the whole purpose of this document is to give you an idea of what we did, and also to give your teacher next year an idea of what we did, right? Because this grade 11 class, what we covered, is probably different than what another grade 11 class might have looked like, right? So, and that happens on a normal year as well. Like, all teachers are different, right? And we all have different priorities and different interests and different skills. And certainly, I know that I like to sometimes give you problems that aren't directly out of the Manitoba curriculum, right? That's sometimes I just find an interesting problem and I think that, hey, yeah, why don't let's play with this for a day, right? So it's not like every math teacher normally follows the curriculum like perfectly, right? There's always going to be some things that may get swept under the rug. There might be some extra stuff that are thrown in, but this year, especially with the remote learning, there's a huge difference between one class and another. And then this document, the purpose of this document is to outline what we did. So this is both for you and for your teacher next year. So that is the purpose of this document. So I hope that makes sense. So do you guys have any questions about it? Any concerns? Do you notice anything weird about it? Yeah, you can think of it kind of like a review. So I wouldn't, like, if we were doing a final exam, which we're not doing a final exam, but if we were, I would not consider this to be an exam review. So it's not like this is something that would be like an exam review. If it was an exam review, then I would have much easier questions on it as well. Like, I would have like warm-up questions. But I didn't put any warm-up questions on here. These are all questions that I think that we can really learn a lot from. So that's kind of the purpose of this document, is to give us something to kind of sink our teeth into. I think that the questions on here are actually really good questions. I put a lot of thought into choosing which questions and kind of leveling them out from level 1 to level 3. So I think, like I said, like, this is not a final exam, or it's not a replacement for a final exam. Like, this is for you. If I were you, I would spend some time between now and September going over this document very thoroughly. At the very least, I think that everyone in this class should go over the level 1 problems and make sure that you can do all of the level 1 problems. And like I said, the level 1 problems are not easy. Like, these are not intended to be easy problems. Like, it's not like level 1 is like level 1 of a video game where it's like, oh yeah, this is just like a warm-up and easy. Like, level 1 almost doesn't even count. Level 1 is just like there's 3 levels, so we have to call it something. It's just it should have been called like type A, type B, type C or something, right? It's not like level 1 questions are easy. Like like this simplify and state all non-permissible values in the expression x squared plus 5x minus 24 over x plus 3. That's a hard question. And you wouldn't have been able to answer this question last year. But I think that you can answer it now, right? So I would go through, make sure that you can do all of the level 1 problems. And if you can't, hit me up over the summer and see if I can help. Like the level 1 problems are all things that we've gone over very carefully. And if you feel confident in yourself and you feel like you do know all the level 1 problems, then start looking at the level 2 problems. And I'm hoping that a lot of you actually can do the level 2 problems. The level 2 problems are kind of like, okay, like, so you understand the basics. Like, can you apply that? Can you kind of push yourself a little bit harder? Can you make some connections? Can you do like a little bit of like deeper calculations? And then the level 3 is like, do you really know your stuff? Like, do you know this inside and out? And that's what the level 3 questions are for. And I'm hoping that that maybe about a quarter or a half of you can answer all, if not almost all, of the level 3 questions. I don't expect that everyone can answer all of the level 3 questions. I'm just being realistic. They're not intended to be answered by everybody. But these are the types of questions that you can answer given the knowledge that you've learned in this class. Like, there's nothing from these questions that go like outside of the scope of our class. You just really have to know your stuff, right? So I'm hoping that quite a few of you are able to do the level 3 questions, but I know that they're not for everybody. Like I know that. I don't have any sort of false hope. I know that some people just generally struggle with math more than others. But I still think it's worth it to try the level 3 problems. I think everyone should try them and at least be aware, like, what are some of the questions, like how far can this class go, right? So yeah, that's pretty much it. Any other questions? Mm-hmm. You guys are so polite. Yeah, so I mean, it's not like I'm gonna walk over to their room and give it to them, but the math department, which is comprised of all of the math teachers at Grant Park, so anyone who teaches a math class, even if they teach classes that are not math as well, but if you're a teacher who teaches math at Grant Park, you're part of the math department, and we have a shared Google Doc or Google Drive folder. And all of these curriculum review documents are in there. So we're all working on them right now. So I have, I guess I have 5 of these documents to make. You guys are lucky because this was the first one that I made. And so I've got 4 more to make. And all of the other math teachers at Grant Park are creating these as well. And we are sharing them with each other in Google Drive. I'm not 100% clear on how it would work if you go to a different school and how the teacher would access it. From what I understand, there will be kind of a very shortened version of this document baked into your report card. This report card that's coming, your June report card, will be unlike any report card that you have ever received. It'll have a different format. It'll, like, on first glance, it'll look the same. It's like the same font and everything, and like it sort of looks the same, but there's a lot of extra information on it that hasn't been on there before. And basically, so in addition to, like, you know, a reflection on your skills, like a regular report card has, there will also be kind of a statement about what was covered in the class and what the big ideas are in the class, and basically saying, okay, so this is the student's grade, right? But the thing is, normally you can kind of just assume, okay, well, this grade is based on this portion of the Manitoba curriculum. But because there's kind of an understanding that not all teachers taught exactly the same things during the remote learning, and that some things may have had more emphasis than others, the idea is to include that information in your report card. So from what I understand, if you go to a different school next year, your teacher still will be able to kind of get the big ideas, but it won't be nearly as in detail as you would get if you stayed at Grant Park and you just went to like I don't know, like maybe Miss Evans Helmer's class or something like that, and then she has access to this exact document and she can see exactly the type of questions that we focused on. So yeah, that's the idea. So next year, like the classes that I am going to teach, like I will take a look at the grade 10 Intro to Applied and Pre-Cal document and kind of get a sense of what the grade 11 Pre-Calc students have under their belt. So I can kind of make an assessment. And then what I plan on doing, and I know that different math teachers are planning on doing different things. I know that we've had a lot of meetings lately just discussing some different ideas for next year. But I know that what I'm planning on doing is I'm going to take a look at the document that's given to me that outlines what last year's students did, or I guess technically this year, but I'm talking about next year. So I'll be taking a look at the document for the what my students did this previous year, and I'm going to make my own sort of diagnostic assessment tool and basically just choose questions that are very similar to that document, and then I'll just give like a quick test to all my students. The test won't be worth any marks, but I'll kind of take that and make like myself a little spreadsheet and get an idea of where all the students are at, and if there's big gaps, then I'll kind of do a review session on those particular topics, and that's my plan. But there's no set rules about how this recovery learning is going to work. So your teacher next year may do something completely different. But if they're at Grant Park, then they will have access to this document, and this document kind of outlines all the nuts and bolts of what we did. So, does that answer your question? Yes, yeah. So if you do switch from PreCalc to Applied, then your teacher will be able to see that you did PreCalc. So basically, like when we take attendance, we use a program. The program's called Mayet, and in Mayet, you can get like a little profile of all the students, and you can see all the classes that they've taken in the past. So yeah, they'll get to see that. Oh yeah, you did PreCalc. And then they can refer to this document. Yeah. Yeah, no problem. Lance, you had a question too? That's all right. You could still ask it unless you want to save it for later. Yeah, go ahead. I don't know. So if you're watching on YouTube, the question was, do I know if we are starting school early, as in before Labor Day, right? Because I think that's the big question on everyone's mind. I think a few weeks ago, Brian Pallister recommended that school divisions in Manitoba open 1 week earlier than normal, and I think the reasoning behind that is because there's an assumption that there's some lost time throughout the pandemic, and that this would be an opportunity to make up for lost time. So that's his reasoning. I'm not saying that I agree or disagree, but that's my understanding of the rationale. So from what I understand, I think that it's still up to the school divisions to decide this for themselves. So at this point, I haven't heard anything about which day that we are opening, but I know that it has been recommended that we start before Labor Day, but I don't think it's been determined whether or not we will. So yeah, that much I do not know. Yeah, 1 week is not going to teach me a whole semester. Yeah, that's yeah, true enough. Any other questions? No? Okay, so I'm gonna sign out in about a minute. I'll be at school tomorrow, and while I'm there, I'm going to kind of polish this document, make it a little bit, just make sure I don't have any like spelling mistakes or anything. I'm pretty sure I don't have any spelling mistakes, but you never know. I'm gonna go back, edit it, make sure that it's good. I'll add a little introduction, kind of explaining what the document is in a little bit greater detail, and then I'll put it on Google Classroom for you. Okay. All right. So I'm not going to see you tomorrow. So have a good weekend, and I'll talk to you guys on Monday. Bye bye.